In multicasting, any cast RP is one of the feature. If you like, you can use. What it is, you may have multiple RPs, but instead of giving different IP address to RP, we are going to use the same IP address so that the nearest RP will be used. The group members and the source will go to the nearest RP. You remember in the previous class we used MSDP for synchronization between RPs. So instead of having two different IP address, in our case we used 6.6.6.6 as one RP, and then 4.4.4.4 as in another RP. Instead, you can use same address on multiple RPs so that the nearest will be used. And if that one goes down, routing table will automatically point towards the next nearest. That is taken care by the routing protocol and the routing table. So you don't need to worry about how the traffic will go to next RP. If first RP goes down, the nearest RP goes down, because the network is same. If the nearest goes down, based on the cost, it will go to the next nearest, isn't it? The routing protocol, when there are two routes for a destination, it will always show you the nearest one. If that nearest goes down, it will show you the next nearest. Automatically, the routing will do this. You don't need to. It's not an additional thing that you need to configure to achieve it. It is by default. That is what normal routing is, right? So the anycast RP, anycast is nothing but one to the closest. That's the meaning of anycast, one to the closest. So you remember in the previous class, when one RP goes down, it takes some time for the other RP to get recognized. Yesterday, when we shut down 6.6.6.6, it took some time for router 7 to learn about 4.4.4.4. So that time you no need to waste, because as soon as the closest RP goes down, the routing table get converged with a new route pointing towards the other closest RP. Did you understand this point?
Yes.
So none of this router need to change their RP address, the same RP address, but they will be talking to the next nearest one when the closest one goes down. This is more faster in convergence than having different IP address. All right, so this is using the static RP. We were using BSR, so let us keep the BSR itself, and we are going to have anycast RP. Here is the example. You see, there are two RPs, and if you notice this, let me cut this picture and then write down. If you see, this is the RP's address. It's the same address on different router, and you got the same IP address. According to this router, this is the nearest RP. According to this router, this is the nearest RP. And MSDP is to merge them. All right. I don't want this. So this RP is 2 hop away. 2 hop away. This RP is just 1 hop away. In case if this goes down, the same address will be available via this path. Fast in convergence. That's what anycast RP is. So this is the configuration. You see, originator ID, we are going to use originator ID. We used it in the previous class. Connect source. The originator ID is loopback 0. That's all actually. There's nothing more to do. Just like this. MSDP, IPPIM It's the same address, and we are going to see how it works. Uh, Nothing big to learn here. It's a known fact, normal routing. So we're going to remove all those previous configurations that we have made with respect to the BSR and the MSDP, Multicast Source Discovery Protocol. I'll go to router 6 and type show run section IP pim. You see, this is the BSR candidate command we gave. I'm going to remove this first. I'll use a notepad to remove it. And also, that's it. That's it. No. No. One more thing I want to remove is MSDP. Show run section IP MSDP. What? Section MSDP. Surprisingly, I don't have that configuration. Maybe I did not save it in the previous class. Show MS IP MSDP peer. Nothing. So no MSDP. Fine, fair enough. Now let's move to router 4 and check MSDP. Show run section IP MS. I do have the configuration here. I'm going to remove this. See, the second statement we did not write. It will come automatic. Right, I'm going to remove this first. Done. Likewise, I'll also remove from router 6. Done. Okay, now what is next? I'm going to choose one address as an RP address common for both router 6 and 4. Which one? Interface loopback, I'll say 46. IP address is 46.46.46.46. IP pim sparse mode and IP OSP of 1 area 0. So we are running pim sparse mode, and we have advertised this network in OSPF. Now the same thing I'll also do it on R6. Show history. This is it. On R6. Now what is next is if you go to R7 now, R7 will be pointing towards R6, whereas R3 will be pointing towards R4 for the same address. Let me show that. On R3, if I trace route to 46, 46, 46, 46, you'll see it is going to router 4. But if you go to router 7 and trace route, the closest will be going trace route 46, 46, 46, 46. You see, it goes to router 6. So they are using the closest one, okay? Now this is the address I'm going to use as an RP address, right? So as I said earlier, we are going to use BSR to do this. You can also use static, but let's do something advanced. 46 loopback. Right, so this is going to advertise. What is this? Loopback 46 isn't there? What's the loopback interface name I used?
On R4 and R6.
Oh, I'm in R7. Right, so we have configured on R6 I was trying on R7, that is why it was showing error. Now let me put it on R4 also. Done. Now this is going to advertise RP, no doubt, but there won't be sync. That is a problem. You see, if you go to router 6 now and check show IP mroute, you have 239.111 requests coming from to interface. The RP is easy, RP is already discovered. But according to router 6, this is just next router. Next router. And according to router 3, if you see the RP, show IP mroute, it's the same. Okay, it's not showing here because we don't have any local group member. Let's go and check it on R2. Show IP mroute. This is going to show you RP, but if you try tracing the route to RP, it won't go to router 6, it will go to router 4 only. And if you see the source, router 1 is the source, okay? Router 1 is the source. If you see source, the source is knowing only about R6. The source is knowing only about R6. It goes only to R6. So source will go and register with whom? Only R6, not with R4. You see, ping 239, 101. It gets response only from 5 and 7. 5 and 7. It gets response from both 5 and 7. 5 and 7. How come router 6 knows about? But let's see. Show IP mroute, which shows that the outgoing interface is F0 1/0. So it is sending only via this way. It is sending only via this way, not via the upper way. According to router 1, there is no receiver on the upper way, upper path. Because according to R1, the registration happened here. Alright, so how R2 learned? R2 should have learned from R4, not from R1 directly. Let's see. R2. Show IP mroute. R2. It has learned about this from incoming interface of 00. Let me try to trace route again. Ping source loopback 0. Okay, let's see who all responses. Only 7 responding. This is what I want to show you. Only 7 has enrolled with R6, where registration of source has happened. R1 cannot register with R4. As a result, see, as a result, R4 don't know the source. Go to R4 and check. You will not see 1111 as a source. Show IP mroute. R4 don't have any 1111 as a source. These are all old, directly connected somehow. R2 advertises it. When I source with 111, R4 has got no idea about the source 1.1.1.1. Whereas R7 show IP mroute, it knows 1111 source. It knows it via F00. R7 do not know. Sorry, R4 do not know. The reason is R4 and R6 is not in sync. That's why we need MSDP. Let's go to R4 and say IP MSDP peer. The peer is you need to give the router ID of R6. R6 router ID is 6.6.6.6. Connect using interface loopback 0. IP MSDP source. 1 minute. We need to give an originator ID, a common ID on both sides that is more safe. Originator ID will be 1. Originator ID. Same loopback 0. Right, I repeat the same on another router. Do show history. Router 6. IP MSDP peer is 4.4.4.4. Connect source loopback using loopback 0. IP MSDP what ID? Originator ID. ID is also loopback 0. That's it. Now this is going to bring up the peering between 4 and 6, and then you will see the reachability. Show IP MSDP peer. No peer is found. It's in a listening state. Ping 4444 using 6.6.6.6. The ping is happening. Anytime MSDP should come now. Okay, it has come. MSDP peering is come. Now if I go to R1, or before that I'll show you in R4 itself. Earlier R4 was not knowing about source 111, but now it, wait, let us ping. When you ping you will see. It will generate now. Try again. See? Now if you go to R4, which is an RP, it knows about 111. There is a sync between. So router 2 has learned about the source from router 4. Let me also enable the group member in R5 and you will see this. Interface loopback 0 IP IGMP join group 39.1.1.1. Show IP PIM RP address. If you trace route from here, it may go to 4 or 6 because the cost is same. Let's see. Okay, it goes to both 6 and 4. Anyway, it has got multiple paths. It will use both the RPs. Now let's go and ping from R1. I should get response even from 5. Try again. Right. So this is it. In source-based multicasting, which is PIM version 3, see the default is version 2. In PIM version 3, when you configure IGMP, you can specify I want only from this source, you see. Interface loopback 0, IP IGMP, join group 239.1.1.1, source command. You can say from which source, if it comes, you want to join. And this will work only if you use version 3 of PIM. Now the difference between version 2 and version 3 is only this. Version 3 has got an option for you to join the group only if a particular source provides the data. Only a particular source provides the data. Version 2 supports BSR. Version 1 don't support. These are the differences. There is also one more concept called bidirectional PIM. Bidirectional PIM. Right now, if you type show IPM route, you see a source, right? What if there are many sources for this group? Let us assume, like, we are all in conference meeting, and whoever pushes the mic button, they become the source. So if 10 people are in the hall, all 10 is a group member, all 10 are group member, and all 10 are source. You know why? At any time, anyone will press the mic button, and they will talk to you. So if all the sources come getting learned in the M routing table, it will be too much. It will be unnecessary also. That's why we enable bidirectional PIM. When you enable bidirectional PIM, source will never be learned. It will be always star. That's all. There is no big difference. See bidirectional PIM. Bidirectional multicast tree. So it's not a source-based tree or a shared tree. It is bidirectional, not supported in all iOS. It's supported in very specific iOS XE images. And the main thing is source will never be learned. There is no register encapsulation of data for the source to the randomest point. This is the secret. This is the difference. This is what yeah, main difference, but it's not so important. I'll show you the command, but we'll not be doing this lab. Just one command. And this is not the command. This is normal enabling multicasting in iOS XE. This is the syntax. We say IP multicast routing. In XE, you need to say IP multicast routing distributed. And this is it. That's all. IP PIM BSR enabled. Let me try doing that if it is supported. IP PIM BSR bidirectional. Oh, it's there. Okay, so I'm going to do this and show you quickly. I need to paste this on every router. R4 is done. R6. Let's see only on R6 and R4. Now I'm going to run again the command, ping command. And I do not want to see anywhere in the M routing table of R4 and R6, I do not want to see the source. I should not see the source. All right, that's what. Show IPM route. Oh no, I do see the source. Clear IPM route. That may be from the previous. Let me clear. Let me also clear on R6. Now let us try pinging again. One more should come now. 7. 2, 5, 7 also should respond now. I'm waiting for 7. Okay, it has come now. Let's go to router 6 and check. Show IPM route. I do see. Now let me try from different source. I'll make R3 as a source. R3. Ping 239.1.1 source loopback 0. Okay, router 2 is responding. Okay, all are responding. Let's go to router 4 now and check whether it will show. It shows 3 and 1. No, no, no. See, to avoid this, see how many source for the same multi. To avoid this, only we enable bi-directional PIM. I think I have to enable on every router, not only on RP. So let me go to all the routers and put this command, which we just configured. Okay, all the routers are enabled with BSR, so bidirectional PIM. Let's go to R1 and try pinging now. Let's move on to the router 4 now. Show IPM route. No, still I have it. Let me clear and then try. Oof. 6. Come on, 6 and 4 need to be clear because there is MSDP. They may get synced immediately when I clear from 1. So clear, 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 clear. Show IPM route. Okay, cleared. Router 6. Show IPM route. Cleared. Now I'm going to make a new source. This time the source will be RP itself. It's okay. RP itself will be the source ping 239.101 with a source of 6.6. Okay, now let's go and check on our 4. It shows the old entries 333, which is it is copying from other routers. See, wonderful, it worked. See, there's no 6 entry. All right, there is no 6 entry. Let me try picking from 1111. Now let's check it on our 4. Good. Oh, no, 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 no. No, something is not working fine. Okay. Let's go back to the document. I don't think I'm making a mistake. Maybe this is only supported in iOS XR. Let's see from the top. So yeah, see, this is what. Support of bidirectional multicast. It's only in this. So though the command is available on the image, it's not working as I expect. You see, you see, they show you the output. Nowhere source is shown. It won't show you a source. There won't be any source in the output. Yep. All right. So all the necessary, important, most important, less important of multicasting is covered.